Hello guys, welcome back to our channel. So today we are going to solve LeetCode 2906. This is the problem we are going to solve today. So we are going to solve every problem every single day. So make sure to follow us along with it to solve every problem. So if you have any doubts, ask in the comments. Once we see the comments, we will let you know and answer this question. So let's move on to this problem. So you have probably seen this classic problem. So given an array and built a new array where each element is the product of all other elements like that. So today we are going to do the same exact thing, but we are going to do in a 2D matrix. Okay. So here every element of the output is the product of all elements in the grid except the one at the current position. And there is a one twist. We take everything with the modulo of the value 1, 2, 3, 4, 5. Okay, so this is what we are going to do. So let's see the basic foundation of this problem to solve it. So first, there is 1D product array pattern. So for example, before 2D problem, we'll first nail it the first 1D version. So it's in the LeetCode 238, that is product of array except itself. So for example, they will give an array. So like this, there is an array. It is a only array. So A, B, C, and D. Like this, there will be elements. So here, as you can see, we have to give the value. For A, it is B multiplied by C and multiplied by D. For B, it is multiplication of A, C, and D. For C, it is multiplication of A, B, and D. And for the D, it is multiplication of A, B, and C. So by this way, we have to solve this. So in the brute force approach, we can just iterate through it, and for each position, we multiply all the elements and except the same element. We can just skip the same element and multiply and do it. By doing in an optimal way, for example, in a single iteration, we can use prefix sum or suffix products like this. Prefix or suffix products. So for example, if we see a prefix products, let me take an array. So in this array, it is A, B, C, D. So here, let me take the single array and A and B and C and D. So these are the elements in array. So the prefix is that I can say that for this value, the prefix is 1 because no other value is before that. For B, the prefix is A. So for C, the prefix is B as well as A. So we can say AB or A multiplied by B. The next one is for D, it is A multiplied by B multiplied by C. So this is the prefix of this array. So if you take the suffix of this array, so suffix, it would be, we have to take it in the backward. So for this value, it is 1. And for C, it is B. And for A, it is B multiplied by C and multiplied by D. B, C, and D. For B, it is C and D. So C multiplied by D. For C, it is just D. For D, it is simply 1. So this is the prefix and suffix of this array. So combining these two values, so for example, if you just simply multiply these two values, so for example, we can just multiply this prefix and suffix. So B, C, D. We got the exact value for the first one. So for the second one, it is A, C, and D. We have skipped the B. So computing the previous value and the after value, and we multiply it. So using this method, we can solve it in this 1D array. Okay, so this is how we are going to do it in the 1D array. So we compute the prefix in left to right path and the suffix in the one right to left path. And combining this, we can just give in a big O of n time, and there is no extra space. It is in a simple constant space. So this is the pattern we apply. We are going to apply it to this problem. So, but in a 2D array in the linear order. So let's try it. How to do that? So they have given a zero index 2D array. So they have given it is a grid. So the size is n cross m. So we have to define the product matrix of the element P, where each element is equals to the product of all elements in the grid. So after by doing that, we have to take the modulo by the value of 1, 2, 3, 4, 5. So why they have asking to do this 1, 2, 3, 4, 5? Okay, because it is one of a this 1, 2, 3, 4, 5 is not a prime number, and it is 3 multiplied by 5 multiplied by 823. So the product of many integers can grow astronomically larger far beyond what even the a 64-bit long can hold. So taking the modulus with this 1, 2, 3, 4, 5 at every multiplication, so this will help us to keep our number bounded. So the answer of each cell should be always in the range of 0 to 1, 2, 3, 4. So here make sure that as you can see, this is not a prime number because it can be also divided by cell. Okay, so this is not a prime number. So the modular inverse does not exist for all of them. So we cannot compute the total product and divide by the current element under it modular. So we must use the prefix and suffix approach. Now we don't have to use the division approach. So let's take this grid. So they have given this is the grid. So as you can see here, let me remove all of them. So this is the structure. So here 1 and 2 and 3 and 4. So for this array, it is this element, we have to multiply these three values. So 3 multiplied by 4, 12, and it is multiplied by 2 again, it will be become 24. So let me give the final array. So it is 24. Next element is 12 multiplied by 1, it is 12. The next element, here 8 multiplied by 1, it is 8. And here we skip this element, so 3 multiplied by 2, it is 6. So we got the value. So this is how we are going to do that using the prefix sum and the suffix sum. So using this we can simply do that. So we can just go for the next one. So next problem is example 2. For that they have given 1, 2, 3, 4, 5 and 2, 1. So it is an one dimensional array. Even though it is a grid, it should be given, it have given in that way. So let's calculate for this example. So here let's see. So in this element, as you can see, the first element, the 0 of 0 is 1, 2, 3, 4, 5. So next element is 2 and the final element is 1. So see here, in this element, we can just skip it and multiply these two values. And if we return 2 as the first element. For the second element and third element, these two are zeros. Why? Because we are going to use modulus operator. So by using here, what you are doing, so first you will multiply this value. So 1, 2, 3, 4, 5 modulus 1, 2, 3, 4, 5. So this is the same value. So the remainder is will become 0. And for this value, it is multiplied by 2 times. So even if it is multiplied by how many times, it will be divided by the 1, 2, 3, 4, 5 that value. So that time also it should return the output as 0. As you can see, this is the value, and it is while you are using this modulus operator using this value, it will always return value as 0. So let's see the constraints of this. So the value is the length can be 1 to 10 to the power of 5, and number of rows and number of columns can be 1 to 10 to the power of 5. After that, the multiplication of that means the row multiplied by column will be in the range of 2 to 10 to the power of 5. So the next one is the current element. So the element can be in the range of 1 to 10 to the power of 9. So let's see the key insight of this problem to solve it. So the key insight is we have to treat the 2D grid as a flat and 1D. So we are just going to see it as a 1D array. So for example, in the first example, let us take this. So as you can see, it is indestructible. But here we are going to see it as indestructible. We are going to convert it like a 1D array. This is how we are going to solve this problem. So here we have to visit each and every cell, and after that we can calculate the prefix sum, prefix product, and the suffix product. So by calculating these two products, we can just multiply the values and return the value. So we are going to go from left to right and top to bottom in the linear position. So, but we don't actually flatten this array. So we are going to just visit the nested loops in that order. So first we traverse from bottom to right. So in this bottom to right means we are going from right to left. And in the top left cell, so like this. So bottom right to top left cell. So here we store the suffix product and the product of all elements after the int in the row of major order. So here we maintain a running variable. So we can name it as suffix. So the product of everything after the position of int. So here we will multiply the value with the current value and modulus the value. Same like that, we have to go from left to right. So here it is left to right like this. 1, 2, and 3, 4. So we traverse the grid from top left to the bottom right. But for the right to left, we have to iterate from this bottom value to this value. So for the suffix, we have to start from 4 and end at 1. For prefix, we have to start from 1 and end at 4. So these two passes, we can just multiply the value and just return the value. So let's see the solution for it. So first we have given the modulus value. So it will not change anyway. So we will make it as constant. Modulus 1, 2, 3, 4, 5. So this is the value. So the next one is the grid size, that is the number of rows and columns. So int n is grid dot list, and for m is grid of first element. So we have to get the number of rows and number of columns and stored in these two variables, and after that we have declared a variable for this modulus. So the next one is they want 2D vector as the output, and they have given 2D vector as the input. So here we have to create one 2D vector to return the output. So for that, let's create one 2D vector. So vector and vector. So within that it is integer data type. So we can give any name. So but I like to give P. So for that we can create this matrix as P. So because it is nothing but the product values, so that's why I given P here. The next one is the n. So the n for number of rows and the vector, yeah, array will be stored here within this array. So for that, it is in the vector integer type. Okay. So within this vector, it is initialized with the value of 0 with the size of m. So m elements will be initialized with 0 and then n for number of rows, that is the number of vectors will be stored within this vector. So after that we can end this line. So we have created one n cross m output matrix and initialized all with 0. So we fill it with the suffix products from the pass 1, then we will multiply from prefix product in the pass 2. So all values will be within the range of 0 to in the range of 1, 2, 3, 4. So it will be fit within the integer value. So there is no need for giving us long. So integer is enough. So let's do for the first pass. So let's name it as pass 1. So suffix. So here we have to calculate the suffix product. So let's use a long. So which can store the higher value. So let's name it as suffix as 1. So now we have to iterate through the last term. So for I is, we have to iterate from the last element. So n minus 1. So it will lead to the last row. And after that, I greater than or equals to 0 and I minus 1. For the next inner loop iteration, here in j is n minus 1, the last element in the, this is for the going to last row and this is for last element in the current array. So next one is j greater than or equals to 0, j minus. So using these two loops, we can iterate through this array and after that we can find the value. So now the current element is the p of I and j will be the current value of suffix. Okay. So now we'll make it as the current suffix value. In the next one, we have to change the value of suffix with the multiplied of current value. So suffix will be multiplied by the current value in this array. So here it is the grid element. So grid I and j. So here it can hold the value. Okay. So now what we have to do, we have to do modulus operation in the every multiplication of. So here modulus variable. It is modulus by modulus variable. So we have pass. It is the first pass. Next one is the second pass. So pass to prefix and it is suffix. Okay. So now we have to iterate from the first value. So let's create one more variable to store the value. So long. So prefix in the sense of font. So next one is we have to iterate from the first element. I is 0, I less than n, I plus 1. J is 0, j less than m, and j plus plus. So now we will iterate through this grid once more from topmost left to bottom right. So now the current element will be changed with the value of the prefix value. Now the prefix value will become prefix value is multiplied by the current value, that is the grid of E and J modulus 1. So now we have the value. So we can just multiply the value. But here we missed one more thing. That is, here we have to store the value with the multiplication of these prefix values as well as the suffix value. Correct? So here one more thing we have to do, that is first we, first we have to type in it because the multiplication value will be higher. So for that we are type converting it to long. So then this value is, it is the current value of element is already holding the value of suffix. So for that we have to multiply the current value with the prefix one. So now it can store the value and multiply. So why we are typecasting is because this value is long, but it is integer value. That's why we are using it. So after doing these much values, we must do the modulus operation, or else the integer cannot hold the value. So after type converting, it will be multiplied with this value and the modulus operation will done. So there is no need for any parenthesis here. So after that, we are doing this. We just need to return the 2D vector. So return. So let's try to run this. So the problem is being accepted. So let me explain one more time this problem. So it may look hard, but this is a very easy problem. So let's see it. So first, see what they have want. They want 2D vector. So I have created one 2D vector to store the values, and this is the modulus value. We have to use modulus operator with every calculation so that I am stored in a variable. The next one is integer n. So it is nothing but the number of rows, and m for number of columns. So after that we have created one 2D vector. So in this it have n rows which will store a one dimensional vector. So in that vector it is the size of m and it is initialized with the value 0. So now we have to calculate the suffix value. So we have thinking that this is this 2D array as an 1D array. We are not changing anything, but we are just thinking it like that. So we are iterating. So we are iterating from the last element, that is 4, to the last element, to the bottom right element, to the top left element. So by doing that, here as you can see, using this we can the last row, last element from the the initialized value, the top left value. So that is I0 and J0. So the next one is we are storing it in the current value of suffix value here. After storing it, we are multiplying the value. So next one is prefix one. So in the prefix, here we are storing one more variable and we are multiplying the value. Here we are we already stored the suffix value in this one dimensional array. So now we are multiplying the suffix value with the current prefix value, and we are doing the modulus operator, and after that we are storing it in the variable. Finally, all the values will be multiplied and stored in this product vector, the 2D grid. So now we can just simply return it. So let's submit this problem. So all the test cases are being passed. So let's see what are the basic mistakes the commonly people would do. So first, for this prefix and suffix, we have given long instead of integer. But most people will give integer. So by multiplying this value, it will overflow. So that time we should only use long instead of integer. So before taking the modulus, we are multiplying the value. So doing that thing, it will exceed the size of the constraints they have given. So it will cause the overflow and gives a completely wrong result. So make sure always declare these two values as the long. And the next thing is taking modulus of the end of the multiplication. So here we have to do modulus in every operation. So if you accumulate these products without taking the modulus in each step, the value will grow exponential across this n cross n cells. So with the 10 to the power of 5 cells, it can reach up to 10 to the power of 6, which is impossibly large value. So make sure to always apply this modulus in each and every application. So next mistake is they will try to divide under this modulus. So we have to use modulus operator instead of division. So you can't just simply multiply all of these elements and divide with the current term, because maybe this value may become like 0. So you can't divide any number with 0. So that's why you have to use this prefix sum and suffix sum and just simply multiply it. So we have traversing in the current position. So next one is the first pass in the wrong direction. So the first part of pass must be from the right side bottom to the top left. So here it is going left to right in the pass one. So which is accumulates the prefix product instead of suffix product. So producing it will lead to produce the wrong result. So the direction of each pass is fundamental. So first we have to calculate the backward class for suffix and prefix for forward. And the next thing is people would forget to update this value, or else they would update previously before calculating this current value. So if you do that, the value will collapse and it will not give the correct answer. And one more thing, here we have typecast as the long. So if I remove this, let's see any error happens. So in these test cases, this error is not happening. But if this value exceeds the size of the integer, that time it is a problem. So make sure to type convert this value. So that time it will help to explicitly reduce the value of this value using this modulus operator. So finally we are returning the solution. So that's all for this today's problem. We have solved this problem. We have converted this 2D array in our mind. We didn't change any structure. We just simply changed that and we have solved the problem. Here we have think of it as a 1D array. We didn't change it to 1D array, but we think it as a 1D array. So there is two passes. So the time complexity of this problem would be the grid size. So that is nothing but big O of n cross m, and the next one is there is no extra space here, so the space complexity should be in the constant space. So that is something with big O of 1. So for the time complexity, so it is big O of n cross n. So for the space complexity, big O of, because we didn't use anything other than the single one 2D array, and we have just written it. There is nothing other than that. So this prefix sum product pattern is one of the most reusable pattern along the competitive programming. So you will see it in the LeetCode problem 238, 1352, 2483. So there are dozens of more. So make sure to nail this pattern. So using this pattern, we can solve this much harder problem in a simple, efficient way. And one more announcement, that there is a competition is going on. So that is, if you go to infotechis.com, you can see that. So there is byte battle coding. So here in this competition there are 2 rounds. So you can register it. It is for free. And now there are lot of topics are there. So if you like to compete with yourself, just go there and solve this problem. And they have given everything here, the format and the goal. And for the winners, they have announced some surprise prizes are there. And even if you don't, you will get experience as well as how the competitive programming is there. And as well as you will get the certificate for participation. So make sure to try out this. So if you have selected in this first round, you'll be finalized for the second round, and as well as there will be some advanced data structures, greedy algorithms, and graphs basics as well. So make sure to register it and solve it. There are also 1,000 participants there. So compete with yourself and evaluate how you are doing. So see you in the next slide.